Alright, today we are going to be putting it all together for the MNIST dataset. Alright, let's see. We'll just set a random seed for all the random stuff. We will first make some vectors. It's actually going to be a 2D vector, so vector of vectors for the images, and then we will so this will be for reading the images, and then in the, let's see, in the training for loop, we will convert those vectors into our matrix struct. And like I said in the previous video, you'll just create these. You can use my GitHub to create these functions that I'm about to have for like the read images function. I'm not going to go over that unless somebody ends up wanting me to. Let's see. Let's see here. And these are just the file paths I have to it. Let's see. File name and number of classes. Guess we should make number of classes. I'm just gonna copy these values in. We're gonna have number of samples, so batch size of 10. Learning rate's gonna be 0.01. Number of inputs, so each image is a 28 by 28. The function for reading the images, I believe it is, flattens this to 28 by 28. So basically 1 by, I think it's like 700 and some, which is 28 times 28 equals the 700 and some. Number of neurons, 256. Number of classes, we're going to predict out of 10 classes. Iterations, we can try like 201, see what happens. Check iterations, make it 50, so see at 4 different points roughly. But yeah, this requires number of classes. Okay, so yeah, we've got loading in the images, the labels from the paths. And next we are going to make the matrices for the training images, like the training batch. So num samples is the batch size, and then number of inputs is our basically the size of each image flattened out. And same for the training labels. It's a batch of training labels. So the num samples by number of classes. And then we'll go ahead and make, I'm just going to copy this as well. So this is going to be the structure I'm going to be using here for our neural net. There's going to be a first dense layer with a ReLU, a second dense layer with another ReLU, and final one is a third dense with softmax, got the loss function, categorical cross entropy, and then here's the optimizer. It's undefined. That might not have gotten saved. I think that did not get saved. So give me 1 minute here. Okay, we got update params. These are for future things or just experiments. This one's also an experiment I did. Okay, so we'll save that. Go back over here. Okay, now it's good. One other piece we're going to have here is a vector of random numbers. This will be, it's part of the other, one of the other functions here in gather images. Okay, let's see. So in here, the random vector will be for this get random vector, which is going to get the random sample of, or the random numbers, which we're going to use for the random sample of images. So randvec, and then we'll do the for loop. Goes up to num iters, and first we'll get that random vector. Size num samples. So this is gonna get us a vector of size, our batch size, and get random images as well as those same the matching random labels. So do that. train images is going to take in the images and the randvec to get our batch of training images. Same with the labels. Let's see here. Images, randvec, num samples, and number of inputs. Num samples and num inputs. I will say one issue with this. I have not addressed yet is, since this is just a function, we are, so right here, we're allocating memory to this train images, and we're doing that every time we call this inside the for loop, and that is an issue, just because we're allocating memory and we are not, we're not deleting that memory. And so pretty sure it just creates a copy into here. And then that memory is kind of just left out there, I do believe. Not 100% sure on that, I don't remember. But it works for now, and that can be something to figure out later. And then we just go ahead and go forward, training images, and just go through all the layers. I'm just gonna copy this, starting with the forward. Let's see. Okay, so train images goes through the first layer, go through the ReLU, go through the second layer, second ReLU, third layer, and softmax. And then do the loss.forward. And print the loss, which I'm going to do here. So if we're on a check iteration, print what the iteration is, have a float for a total loss, and then go through each of the let's see here. Oh yeah, so this will be a one row by number of samples columns. Let me double check that. Let's see. Loss. One by number of samples, yep. So we go through all the columns and we're gonna add total loss with each of the negative log likelihoods. And we'll get the average by dividing by the number of samples and print out what the average loss is. And then we'll just go on the backwards pass after that. Let's see, so that's a loss forward. We'll do the loss dot backward of the softmax output. And then once again, I'm just gonna copy and paste and I'll tell you through each one. I'm definitely missing something in that forward, or in this loss step backward. You need the Y values, the Y true values, which are the train labels. Yeah. Okay, so yeah, loss backward takes the output of the softmax and the train labels, which are the Y true values. And then take those D inputs of the loss, go through the softmax, and then all the way back, third layer, second ReLU, second layer, first ReLU, first layer, and then we update our parameters. And that is essentially it. So yeah, we'll print this out. I'll just save this, see if everything worked, and see if we have a loss. See if we, let's see. Okay. So the other file already has that, the images file name. That's already in the gathering images. So, my bad on that. Try this again. Alright, so we got an issue. Let's make this one iteration and see where the issue's at. Still have it. I'll just start like right here. Train images, train labels. All right. Okay, so it's probably not there. I guess it's in train images. Nope, train labels. Whoops. Okay. equals num samples by num classes. Samples and number of inputs. Num classes, I think is what yeah. Okay, so this parameter here is wrong. That's what's up with that. So that's actually supposed to be a number of classes. All right, so that should fix that. We'll see if we got anything after that. So yeah, train labels is equal randomized labels. And right in here, instead of number of inputs, this is supposed to be number of classes. So fix that, save, and play it. And perfect. Got a loss function here. Remember, we switched it to 1 iteration. I'll switch it back to 201 and see if it learns. Let's see here. That could be due to what we started the dense layer, the weights parameters at. Okay, yeah. So for the last thing, we wanted weights at -1 to 1. Now we want it at -0.1 to 0.1. I don't think we used biases on this. Yeah, biases we set to false. So we're gonna save this. Our weights were essentially way too big to start out. There we go. It gets smaller and smaller. If you go 300, it should get even smaller. And there we go. And then you'll have some aberrations. It should get smaller again after this. Sometimes you just have some crazy numbers, which sometimes even a person would not be able to notice what the number is in this data set. But yeah, and that is MNIST. The next one, for the next videos, I will might do the ConvNet, otherwise I'm not sure if I'll take a break from this series and go into some CUDA stuff, or I'll start doing some papers, or a paper, just as an interjection and to get multiple different areas of information going out there. Not sure. Let me know in the comments what you'd prefer to happen first.